Lesson 15.3 is definite integrals with synthetic division. I'm hoping you remember synthetic division from Algebra 2, from pre-calc. It's a quick way to divide polynomials, something that can't be factored and can't divide nicely because it has a binomial in the denominator. So this right now would not be fun to integrate. So what we do for synthetic division is you take all your coefficients, or the numbers in front for your numerator, so that's 2, -11, 7. Make like a big L shape here. Now the denominator, x minus 5, think of that as a factor. You want the answer to the factor. So instead of x minus 5, think of setting that equal to 0 and solving for x. Really, we want to divide by the answer, which would be 5. So it's always going to be the opposite sign that you divide by. To start synthetic division, you bring down the first number. Then you start multiplying. 5 times 2 is 10. You add these together, -11 and +10 be -1, and then you go again. You multiply. 5 times -1 is -5. 7 minus 5 is 2. Whatever numbers last, that's your remainder. And how you write your answer is this answer drops down a power from the original numerator. So if this was x squared, now this is your x term. So it'd be 2x, and then that must be your constant. To write your remainder, it's going to be positive, because it's +2, over what you divided by, the x minus 5. Okay, so then I'm going to rewrite that I'm really integrating from 3 to 4 of 2x minus 1 plus 2 over x minus 5 dx. So what's happening here is these terms are my normal, just how to integrate. This is from the last lesson when I have a rational function, which is integrating to be natural log of the absolute value of x. So integrating this, remember you always add 1 to the power, so that'd be x squared, divide by 2, so that'd just be a 1x squared. I have a constant, so I tag an x on, and then here it'd be plus 2 times the natural log of the absolute value of x minus 5. Because remember that this is really the same as this. So it's 2 times the natural log of the absolute value of the denominator, and since there's a 1x, I don't need to divide by anything. And I want to find from 3 to 4. Okay, so it's a little lengthier process, but still not hard. Plug in 4, you'd get 4 squared minus 4 plus 2 times natural log of 4 minus 5 minus, put brackets, 3 squared minus 3 plus 2 natural log of 3 minus 5. 4 squared 16. 16 minus 4 is 12. Plus 2 times natural log 4 minus 5 is -1, so it's really natural log of 1. Minus, I've got 9 minus 3 is 6. Plus 2 natural log, that's a -2, but it would become 2. Okay, then I'm going to think about natural log of 1. Remember that's e to what power make 1? That's a 0. So it's 12 plus 2 times 0. And then this should have been, a negative, because I have to distribute this, or think about brackets being around it. But I'm going to go ahead and just make that negative and that negative. And then I've got minus 6 minus 2 natural log of 2. So really I have 12, that goes away. 12 minus 6 minus 2 natural log of 2. 12 minus 6 is 6. Just wants it into a single log, and it is. You could take the 2, make it a power, and say this is just minus natural log of 4, but you don't need to. Okay, let's try one more. Looks a little scarier because your bounds have an e in it, but look what I'm dividing. I have something that's x to the first divided by x to the first. So the synthetic division is really short. Take your coefficients of the numerator, so that's a 4 and an 18. Make your big L shape. We're not dividing by 5, we're going to divide by the answer, which is -5. Bring down your first number, multiply, so you get -20, and that adds to make -2. That's already your remainder. So if this started with an x term, this now drops down and that's my constant. Then I have a remainder of -2 over the denominator, can't even think of the words, denominator of x plus 5. Okay, so rewrite your integral. Okay, so antiderivative of 4 is just tagging on an x minus, this is going to be like a 1 over x plus 5 times negative 2, so it would be negative 2 times natural log of the absolute value of x plus 5 from negative 4 to e cubed minus 5. All right, so plugging in e cubed minus 5, I've got 4 times, need parentheses because I'll have to distribute the 4, minus 2 times natural log of the absolute value of e cubed minus 5 plus 5, all for just the first part, minus brackets, plug in negative 4, so it'll be 4 times negative 4, I'm actually going to just put negative 16, minus 2 times natural log, negative 4 plus 5 is 1. Okay, distribute here, you get 4e cubed minus 20 minus 2 times natural log, negative 5 and plus 5 cancel, so you get e cubed. That would become plus 16. Natural log of 1, think again, e to what power would make 1, that would be a 0, so that's gone. So all I have left is the plus 16. Okay, let's think about this. Natural log of e cubed. The base of natural log is e. So this is saying e to what power would equal e cubed? Well, it must match. It must be 3. So really a natural log of e cancel each other out, and it's just 3. So this is 4e cubed minus 20 minus 2 times 3. And so that would be negative 20 minus 6 is negative 26 plus 16, which is 4e cubed minus 10. And that would be your answer since e is an irrational number.